friends, this is Shresth Suraiya and welcome to my YouTube channel. And today I am going to share with you the solutions of the physics questions of IOQJS Part 1 2022. So let's start. I actually have provided the PDF in the description, so you can check that. It's question paper code 51. So let's start. So the first question says that so we have a coordinate system here, okay, and this is called S1, okay, and then there is another coordinate system. Suppose this is x1 and this is y1, and then there is another coordinate system S2, and let's say this is S2 and the x2 and this is y2. All right. So we know, so in the question they have given that it starts from minus 2 comma 0 in S1, right? So it starts from here. Okay, so this is particle P1. This is particle P1 which starts from here, and so basically if this particle is starting from here and they have given its acceleration as this given its acceleration as 1.25 meters per second square. No. And they have given the time as 4 seconds. Right. So we know that S is equals to ut plus half at square. Right. And since u is 0, we have as half at square, half into 1.25 into 4 squared is 16. Which is equals to, if you cancel this out, you will get 10 meters, right? So it has traveled 10 meters. So minus 2 comma 0 along the x1 axis, it has traveled 10 meters. So you will reach at 8 comma 0, right? Because it has traveled 8 minus 2 is 10. Okay. Now the second particle P2 is starting from the origin, okay, and it is going its acceleration is given as 5 and its time is given as 2, right? So the distance from this formula, that is the second equation of motion, you will get half into a, which is 5 into 2 into 2 square, that is 4 in meters, which is equals to 10 meters, right? So it will travel along the x2, so it will reach somewhere here, okay, 10 comma, so it's basically this distance is 10, right? So we don't know what these two are. Now we are given that the distance between P1, the P1 was here and this is P2, distance between them is 6 meters. So this means that this much is 6 meters, this much is 8 meters, and this much is 10 meters. So this is a 6, 8, 10 triangles is familiar. 3, 4, 5 Pythagorean triplet into 2, right? So every side is twice of that triplet. So this means that this is 90 degree, right? And also one more thing we can say is that this angle theta will be equal to cos inverse of 8 upon 10, right? Which is 36.8 degree. If you use your calculator, you can find it 36.8 degree. Now they had asked the question, the angle between x2 and y1. So that will be 90 degree minus theta, which will be equal to 53.2 degree. So the answer B will be correct. But there's one more thing. There's one more thing that we can also consider the axis as like this. This is x1. Sorry, this is x1. This is y1, and this is x2, and this is y2, right? So if we solve it like this, then you will have to take the angle between you have to take the angle between y1 and x2, which is y1 and x2, right? So this will again be 53.2 degree. But however, if you turn the sides, if you take x2 as this and this as minus x2, then you will get x2 and y1 के बीच का angle, you will get 180 degree minus 53.2 degree, which is 126.8 degrees. So that is also correct. So B and D both are correct. So in the IPT official answer key also they had given B or D. So if so, it's since it's a single correct, then if you can either mark B or D. So if you have either marked either of them, if you mark either of them, then you will get the correct answer. Okay. So let's move on to the next question. So the next question is, so this question was dropped by IPT. Okay, this is question number 18 from paper code 1. So it was dropped because there was a misprint. There was the R was not there, but however I will explain the solution. So basically we are given the equation Z is equals to A into R upon R plus U whole cube, right? But now you know something called a binomial approximation, that 1 plus x raised to the power n can be approximated as 1 plus nx when x is very much less than 1, right? So we have to use this here. So we can use that z is equals to a into, we can divide both the numerator and the denominator by r. So we will get 1 by 1 plus u by r whole cube, right? This is nothing but 1 plus u by r raised to the power minus 3, which is equals to a into 1 minus 3u by r by the binomial approximation. This is equals to a minus 3au by r. Now we have to plot the graph of z versus u, and we have to find the slope and the intercept. So clearly we know that the graph is y equals to mx plus c, where m is the slope and c is the intercept. So here a will be the intercept and minus 3a by r will be the slope. So the option C will be the correct answer. However, if in the paper there was a misprint, then anyways the IPT has dropped this question. So we can proceed on to the next question. The next question is this is related to fluid. So the submarine. So there is a submarine which is kept on Earth, which is parked here at a distance of 200 meters from sea level, at a depth of 200 meters, and they are asking that how deep should it be kept on Mars, right? So basically the depth, or let's not by deep. Okay, and so that it experiences the same pressure. Now see, the pressure here will be P naught plus rho of water, it is rho, so actually rho of sea water, into G of earth into 200 meters, right? And this will be P naught plus rho of sea water into G of Mars into D. Now the point is that you don't need to, you need to assume, you have to assume that the atmospheric pressure of Earth and Mars are same, because they haven't given any information on that. So you have to assume it's pretty trivial that you will have to take them as equal. So you basically have to equate rho of seawater into G of Earth into 200 meters like this is equals to rho of seawater into G of Mars into depth. Now rho of seawater is same, so you can cancel that. So basically you will get D is equals to, and if you put the values, then you will get 9.8 into 200 divided by 3.7, which is 530 in meters. So that is the correct answer. So the answer will be option C. Let's move on to the next question. Okay. So the next question is about oscillations. So they had given a graph. So if you follow that graph, basically the energy is dissipating. Now there's a very long formula for energy, but we just need to remember what it's proportional to. So it's so that there's an amplitude square, there's a lambda, there's a omega square. See, now if you see that the time period is, the time period is constant. Like if you check, the time period of the wave will always remain constant, but the amplitude is lessening. Since the energy is proportional to the amplitude square, the energy of the wave will keep on decreasing. Also, you might have learned this in SSM. This is a very nice concept. see, when the amplitude is maximum, that means that the potential energy is also maximum, right? And when the amplitude is zero, then the potential energy is zero and the kinetic energy is maximum. So it's basically like this. Suppose an object is performing SHM, that is simple harmonic motion, then there are three main positions that we need to study. Okay, so this is when the distance x is equal to 0. This is when x is equal to minus a, and this is when x is equal to plus a. At these two positions are called the extremes or the extreme positions. So at these positions, the potential energy will be the highest and the kinetic energy will be 0. And at this position, the kinetic energy will be highest and potential energy will be 0. Right? So this means that so since you can take from the graph that at t equal to 0, the amplitude is the x is equal to amplitude. That means that the potential energy will be the maximum. So the oscillating motion of an object with damping means decrease of energy, such that the time measurement was started when the system had maximum potential energy will be the correct answer, which is option D. So let's move on to the next question. Okay. Okay, so this question was pretty easy. So if you might have learned in electricity, there's something called a balanced Wheatstone bridge. So it's basically like this. There's a galvanometer, right? R, 2R and 2R, right? And since there's a galvanometer that shows no deflection, that is the current in this will be 0, and you can verify this because R by R is equal to 2R by 2R. That is the condition for a balanced Wheatstone bridge, right? And you have connected this to a 3-volt battery. Okay, 3 volt. Now what will be the equivalent resistance? The equivalent resistance, you can ignore this thing. So it will be R plus 2R, which is 3R, right? 3R and 3R in parallel, right? So it will be 3R by 2. And if you put R equal to 2 ohm there, as it was given, then you will get 3 ohm. And 3 ohm and 3 volt. So from Ohm's law, you can say that the current in the circuit will be 1 ampere. So this question was pretty easy. Now we can move on to the next question. The answer will be A. Okay. Okay. This question was the next question is very interesting. So it's about gears. So what you need to think here is that when you have a gear here, I'm not drawing the teeth. Okay. This is a smaller gear, this is A, and this is a bigger gear B. Sorry, not B. So if you are moving these, then this will move like this, and this will move like this, right? This is a very nice concept because the grooves here, there are some grooves here, suppose, then they will have the same speed that is in this direction. So that's the main philosophy in this question, that you have to equate the speeds. So how can you do that? See, you are given that the omega of A is 6 revolutions per second, which can be converted as 6 into 2 pi radians per second, right? Okay, now A has 16 teeth and B has 24 teeth. Now this is a very important information because using this you will find the ratio of the radius. So the radius of A upon radius of B is equal to the number of teeth in A upon the number of teeth in B, which is equals to 16 upon 24, right? Which is equals to 2 upon 3. Okay. Also the velocity here will be omega A into RA, which will be equal to omega B into RB, because the teeth will move with the same velocity at that point. So you can clearly see that omega B is equals to omega A into RA divided by RB, which is divided by RB, yeah, which is equals to 6 into 2 pi, right, into RA divided by RB, which is 2 upon 3. So which is equals to 8 pi radians per second. First radians per second is also here. Okay, radian per second unit. So you get this as your omega for B. Okay. Now, basically now what you can do is that radius of B radius of A was given as 14 by 11 centimeter, right? So the radius of B will be 21 by 11 centimeter, correct? So now what we can say is that the speed here, see, this is connected to a block of mass m. So since this is moving like this, it will move up with a speed v, which is the same as this, which is v is equal to this thing. Okay, now what we can do is that I'll erase something. I'll erase this for the time being. Okay. Okay. So what we can say is that the speed will be omega b into rb, which is 8 pi into 21 by 11. Right. That will be the speed. Now you can write this as 8 pi into a pi. You can write it as 22 by 7 into 21 by 11. So if you cancel this, then you get 2, and here is 3. So basically this is the speed in meters per second you will get, and that will be 8 into 2 into 3, that is 48 meters per second. Let me check. I think I have made a mistake somewhere. Just let me check the values. Is moving in clockwise direction. Okay, and the radius is 14. Right. This will be 14 by 11. I made a mistake here. So this is not correct. Sorry. I read the values wrong. This will be 14 by 11. Okay. Yeah. So this will be 14 by 11. I'm sorry. And then you will get easily, your answer will be 32 meters per second. Right. And since they are given the time as half second, the distance traveled up, right, d will be equal to v into t, and time is given as half second. So 32 into half in meters, that is 16 meters. Okay. Now the potential energy, this means that the potential energy will increase by 16 by mg h, and h is nothing but 16 meters. So that means that the potential energy will increase by 16 mg. That is option C. So this will be the answer for this question. That is 16 mg. It will increase. That is option C. So this was a pretty good question. I am sorry I read the value incorrect, but it was a pretty good question. The next question is you may see, you may get scared from the question, but it's actually pretty easy. So the next question is basically, see, they are given 300 million light years. So the distance will be 300 million light years. So first let me explain the concept. This is the star canopus, and this will radiate its heat out like this. And suppose this is here, and this distance is 300 million light years. Okay, light years. So it will radiate out in a sphere. If you can imagine, like a sphere, it will radiate out. And what is the surface area of a sphere? 4 pi r square, right? So the surface area of a sphere will be 4 pi r square, where r is 300 million light squares, right? light years, and r is equals to 300, and 1 million is 10 to the power 6, right? And what is 1 light year? 1 light year is basically the distance traveled by light in a year. So that will be into 365 into 24 into 3600, that is the number of seconds in a year, right? Because 365 days, 24 months, and 3600 24 hours per day, and this is the number of seconds in 1 hour, right? And you multiply this by c. Okay, now this is your r, so you get here as 4 into pi into, now I am not multiplying this thing because you can cancel the c here, right? So you will get 300 into 10 to the power 6 into 365 into 24 into 3600 whole square, into c as well, into whole square into c square. We'll write c alag se. Okay. So now what we can say is that this surface area into into the uh, into the energy received per the power received per meter square multiplied by the surface area will give us the total power, right? And that total power we can equate it to mc square by t. Okay, now we can write that as 5 into 10 to the power minus 8 into this thing. Okay, and suppose writing this as a into c square, suppose a into c square. Okay, this will be equal to dm by dt into c square. So as I told you, c square and c square will cancel, and then you will directly get dm by dt is equals to 5. If you solve this, then you will get it answer as 5.62 into 10 to the power 13 kg per second, right? So you can solve it yourself. I am giving that part to you, and this is option C. So like this you can solve this question. This question was moderate because it involved some calculation which is not familiar to students. So this question was moderate. I won't say it was very tough because the previous question was tougher than this. I would regard, because it was rotation. It involved rotation concept, and that is a very interesting concept. So let's move on to the next question. So the next question, basically we have to maintain the heat. The heat taken by the AC should be equal to the heat radiated out by the men. Okay, so we are given that there are 50%, right, and 50% into 100 watt per person, right, and you can multiply this by 4 hours. Okay, and that's it. This will be the heat radiated out by us, and that will be equal to the heat taken in by the AC, right? Now since the AC is 50% efficient, this will be n percent into energy consumed by n into energy consumed by AC. Okay, now n is given as 50%, is half. So you can say that E of AC is equals to, the energy of AC is equals to, percent cancel, right? So you will get 5 into 4 5 into 4 into 2 into nothing, into it is kilowatt hour, and 1 kilowatt hour is 1 unit. So this is basically 40 units. It is option D. So the option D will be correct answer for this question. So this is how we solve it. Now let's move on to the multiple correct questions. So this part was very interesting as well. I found it very interesting. So the first question is of modern physics. So mostly we are taught this in chemistry, and not usually in physics, as it is not covered in the curriculum. But still you can learn this concept. It's a very good concept. So we are given that E is equals to h nu, and the h value was given as 6.625 into 10 to the power minus 34 joule second in the start of the paper. So first of all, they had given the lambda that is the wavelength, as 650 into 10 to the power minus 9 meters, right? And since C is 3 into 10 to the power 8 meters per second, you can get frequency. Okay, this is denoted by this. So frequency is equals to C upon lambda, which is equals to 3. So basically you will get your answer. If you divide it, then you will get 14 into, just a second, let me check the value. 4.6 into 10 to the power 14 hertz. Okay, so this is what you will get as your frequency. That's option A. So option A will be correct. Okay, now moving on to the next option. So the next option will be next option, they are asking the energy in each pulse. So we are given the power as 0.6 watt, right, and the time is 30 ms. So the pulse power will be 0.6 watt into 30 into 10 to the power minus 3 seconds. So watt second, you can write it as joule. right? And we know that 1 electron volt is equals to EV. EV means electron volt. So 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So you can divide this by 1.6 into 10 to the power minus 19 joules in 1 electron volt. So joule and joule will cancel. So basically, if you solve this, then you will get your answer as 1.1 into 10 to the power 17 electron volt, right? So this means our option B is also correct. Okay. So let's move on to the next option. So the next option is saying that each photon. So now we need to use this value which was given by Max Planck, and each photon will have energy 6.625 into 10 to the power minus 34 into 3 into 10 to the power 8 upon 650 into 10 to the power minus 9 joules, right? What I use here is energy is equal to h into c upon lambda. I have substituted as nu equal to c upon lambda. Okay. Now if you solve this, then you will get your answer as 3.1 into 10 to the power 3.1 10 to the power minus 19 joules. Okay. Now what you need to do is the next question. The next question you need to use that the total energy of the pulse. Okay, the total energy of the pulse energy will be equal to n into h nu, right? So if you divide the values that we had calculated in the previous parts, then you will get n is equals to 1. What are the values? Yeah, so it will be 5.9 into 10 to the power 16 photons. Okay, you can calculate it like that because we have calculated the pulse value, and you can use any units. You can either use electron volts or joules, that's your discretion. Okay, so all the options in this question were correct. If you calculate, so this question was basically calculative. So if you calculate all the values correctly, then you have to use the approximations. Obviously, you can't, what the approximate values were given, so you have to use your approximations. Okay, next question was pretty easy. This next question is pretty easy. It's based on electricity. So basically, we have a circuit here. Let me draw the circuit. This is one resistance, and this is another resistance here. So if you haven't noticed it yet, these resistances are in parallel, and this is a V, and we are given that V is equals to 16 volt, okay, and R2 is equals to R1 is equals to 6 ohm, and R2 is equals to 12 ohm. Okay, now if you so first they are asked that is what is the power dissipated in R1, right? So you can say that the power dissipated in R1 will be the voltage across R1 squared upon the resistance of R1, which is 6 ohm. So voltage across will be 16 squared, and because it's in parallel, so both will have the same voltage across, and upon 6 in watt, which is equals to 42.6 watt. So the option A is given that the power dissipated across R1 will be 42.6, so that's correct. So option A is correct. So let's move on to the next option, so you can check that as well. Sorry, I missed this. 12 ohm and V is equal to 16 volt. Okay. So next question they are saying is the ratio I1 upon I2 is equals to 2. So basically we have to use Ohm's law, and since they are in parallel, I1 R1, because the voltage across them is same, equals I2 R2. So I1 by I2 equals R2 by R1, which is equals to 2. So 2 because it's 12 by 6. So option B is also correct because they have given I1 by I2 is equal to 2, which is correct. So we can move on to the next option. The next option says that the total current drawn from the cell is 4 amperes. So first we need to calculate the equivalent resistance. So let that be R equivalent. So 1 by R equivalent equals 1 by R1 plus 1 by R2, right? Which will be equal to 1 by 6 ohm plus 1 by 12 ohm, which you solve, then you will get 1 by 4 ohm. This value is memorized by a lot of us. that 1 by 6 and 1 by 12 means 6 and 12 gives 4. So R equivalent is equals to 4 ohm. So what will be the current? Current will be V upon R according to V upon R equivalent according to Ohm's law. And so we can say that the current will be 16 divided by 4, which is 4 ampere, and they have given 4 ampere, so the option C is also correct. Okay, now option D, now we can discuss it like that, like this one we don't need to solve. Voltage across R2 is obviously equal to voltage across R1 because they are in parallel, and they have given that they are saying that the voltage across R2 is twice the voltage across R1, which is wrong. Na? So the answer will be A, B and C, right? So the answer of this question will be A, B and C. This question was pretty easy. So now we are moving to the last question of this paper, 33rd question. Let me read it out. I'll let me explain it to you. So basically we are given a glass slab, and this is about lateral shift in a glass slab. So we are given this glass slab, okay, and this formula is actually memorized by a lot of us. So this goes here like this. I'll just extend this a bit. In just a second. Okay, so first of all, this is I, this is R, and this is R, and this is I. Okay, now if you extend this here along this, and then you have to take this as X, and you have to find X, which is the lateral shift. Okay, now since this is R, and so this will be I minus R, I minus R. Okay, now X will be what? See, this length is T, so here you have to basically use simple trigonometry. Then this length will be T into T upon sine R, right? Because if you see, then this length, T into sine R, T into sine R, okay, T into sine I actually, because this angle is I, and this length will be T into sine R. Okay, now this length will be T into sine I minus sine R, this length. So let's name them A, B, C, D. Okay, so AB is T. Okay, so let me write it here. AB is T. Okay, so BC will be T sine R, and BD will be T sine I. So CD will be T sine I minus sine R. Okay, now what do we need to do is that since this is X and this angle will be 90 minus I, okay, and this angle will be 90 degree, okay, and this angle will be I, okay. So X will be equal to CD into cos I. Wait, let me check if I'm actually I'll draw the diagram again because it's getting very complicated. Okay, so we have it like this. A ray is coming here. Okay, right, and we are given this as X, the lateral shift. Okay, yeah, so now this is I, this is R and this is R, okay, and now this is I, okay, and this is given as T, the thickness, okay, yeah. And they are given it as a perpendicular, so this will be 90 degree, okay, and this will be I minus R, and then so this will be 90 minus I plus R, okay, 90 minus I, because 90 minus I plus R will be this whole angle, and this will be R, so this will be 90 minus I, okay, so this means this is I, okay, this is 90 minus R, okay, so since this is T, then we can say that this will be T upon cos R, okay, this length. Now if you visualize in A, B, C, suppose, so in triangle ABC it is a 90 degree triangle, na? So T upon cos R into T upon cos R is this, and T upon cos R into this will be X, so X will be T upon cos R into, so X upon T upon cos R will be sine I minus R, right, BAC, so sine BAC, okay, so this is a really nice question, so sine into I minus R, okay, which is our result. So this is basically T into, so this is what we remember, T sine I minus R by cos R, so T into sine I cos R minus cos I sine R, the expansion, divided by cos R divided by cos R. So you can cancel this, and this is what they had given, T sine I minus cos I sine R by cos R. So option A will be correct. Okay, now the next few options are pretty simple. X depends on refractive index nu, which it will depend obviously, because see, we can change the I but we cannot change R, because R will be given as, see, sine R will be equal to sine I divided by mu. So we cannot change, we don't have the power of R on R, na. And since this is dependent on R as well, we can clearly say that that X depends on refractive index mu, because R depends on it, and R is also a factor here. So B is correct. X is independent of the wavelength lambda of light. That is wrong, because see, X will be dependent on lambda, because the frequency of the light will remain constant. So the velocity of the light will be proportional to the wavelength lambda, and which will be inversely proportional to mu. So since mu is dependent on lambda, and and we just proved that mu will be dependent, X will depend on mu, that means that X will depend on lambda, right? So that means that option C is wrong, because they are saying that X is independent of lambda, which is wrong. Okay, now for the last option we can just put I equal to 90 degree. Okay, so if you put I equal to 90 degree, then you will get this as sine 90 minus R, which is nothing but cos R. So T cos R will cancel, and you will get X equal to 2, which is its X equal to T, which is its maximum value. Okay, it can't be more than T, because you can prove it here, you can differentiate it and you can prove it. Okay, this is given here. So we can say that basically the maximum possible value of X will be T, which will be achieved at I equal to 90 degrees. So A, B will be correct. So the answer to this question will be A, B and D. So this question was very interesting, and the whole paper was interesting. It was easy and interesting. 2-3 problems were very tough, and 4 to 5, most of them were moderate, and a few were very easy, like the electricity ones were pretty easy. So with this we conclude our paper, and we are done with the paper. We are done with biology, chemistry and physics. I hope you like this series of videos, and I wish you all the best for the future. Do like, share and subscribe this video to your friends, so that they can also be helped with this video, and subscribe to our channel. Thank you.